In this video, we're going to look at resolving forces on inclined planes. So let's take a past exam question. A box of mass 2 kg is pulled up a rough plane face by means of a light rope. So because it's moving up the plane, I'm going to draw the direction of acceleration denoted by a double arrow going up the plane. The plane is inclined at an angle of 20 degrees to the horizontal as shown in figure 2. The rope is parallel to a line of greatest slope of the plane. The tension in the rope is 18 newtons. The coefficient of friction between the box and the plane is 0.6. By modelling the box as a particle, find the normal reaction of the plane on the box and the acceleration of the box. So friction is mu times r, and we know that mu is 0.6, so it's going to be opposing motion, so it's 0.6 r, and then the box is in contact with the plane, so we have a normal reaction perpendicular to the plane, r, and then we've got the weight, mass times gravitational force, 2g, going down. So a standard technique is knowing how to resolve this. So we always resolve by forming a right angle triangle. So the weight acts as the hypotenuse of a right angle triangle. Must have arrows here. And this is 20 degrees. So the one that contains the angle is going to be 2g cos 20 degrees. And the one that contains no angle is 2g sine 20 degrees. That's how you resolve that force. So the one that contains the angle is always cos, so 2g cos 20. The one without the angle is 2g sine 20. So now that we've got that, we can start resolving. So we're going to say resolving perpendicular to the plane. Resolving perpendicular to the plane. So it's not moving perpendicular to the plane, so we can say r minus 2g cos 20. Because it's not moving, we make it equal to 0. Therefore r is 2g cos 20. We can work that out on our calculator and round our solution to 3 significant figures. So on our calculator, we're going to get 2 times 9.8 times cos. So we get 2 times 9.8 times cos 20. So I get 18.4 newtons. That's been rounded correct to 3 significant figures. So now to find the acceleration, we're going to resolve parallel to the plane. So resolving parallel to the plane. But don't forget, it's moving up the plane. So we have to use Newton's second law, F equals ma. So what's happening parallel to the plane? Well, if we resolve in the direction of motion, so it's moving up. So we do 18 minus, so it's 18 minus 0.6 r. We know what r is. We said that was 2g cos 20. And then we also need to minus the other force coming down, which is 2g sine 20. So we get 18 minus 0.6 times 2g cos 20 minus 2g sine 20 is equal to the mass times by acceleration. So we can divide it all by 2. And just type that straight into our calculator and we get our answer. So we're going to say 0.5 times by 18 minus 0.6 times 2 times 9.8 times cos 20 minus 2 times 9.8 times sine 20. And so we get 0.1, 2, and 3. Meters per second squared. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we've got a particle of mass 0.8 kg is held at rest on a rough plane. The plane is inclined at 30 degrees to the horizontal. The particle is released from rest and slides down a line of greatest slope of the plane. The particle moves 2.7 meters during the first 3 seconds of its motion. Find the acceleration of the particle. So for part A, we're going to do a suvat. So let's do a suvat. So we know it moves of displacement 2.7 meters. It starts from rest, so u is 0. We need to work out the acceleration, and the time is 3 seconds. So I'm going to use s is ut plus a half at squared. So I get 2.7. Well, u is 0, so that goes to 0. Plus a half a times 3 squared is 9. So I get 2.7 is equal to 4.5 a. So a is 2.7 over 4.5. And we can work that out on our calculator. Just 3/5 meters per second squared. And then we want to find the coefficient of friction. So let's start off by drawing a diagram. In mechanics, it's very important you draw clear diagrams. So we have an inclined plane. So let's draw a line here. We have our particle. Let's go back to the question. It says it's 0.8 kg. So the weight coming down is going to be 0.8 g. It's trying to slide down the plane, so we need the acceleration going down. A normal reaction perpendicular to the plane. We also know that there's friction involved, so it's on a rough plane, so there is definitely friction. So we're going to call that mu r. So mu r is opposing motion. So now what we're going to do is we're going to resolve the forces. So don't forget the weight is always the hypotenuse of a right angle triangle. So we need to go back and write down what the degrees is. So it's 30 degrees to the horizontal. And this is also 30 degrees here. So the one that contains the angle is always cosine, so it's 0.8 g cosine 30, and this will be 0.8 g sine 30, and then we're in a position to start resolving now. So I'm going to start off by resolving perpendicular to the plane. So we're going to say r minus 0.8 g cos 30 degrees equals 0. So we can say r is 0.8 g cos 30. So now we're going to resolve parallel to the plane. So what's happening parallel to the plane? So we always resolve in the direction of motion. So the force that's coming down is 0.8 g sine 30. So 0.8 g sine 30 minus mu times r. So minus mu, and we know what r is. It's 0.8 g cos 30 degrees. Don't forget it's moving, so we've got to say mass times acceleration. So we know the mass is 0.8, and we worked out the acceleration to be 3/5. So it's going to be 0.8 multiplied by the acceleration, which is 3/5. So half of 0.8 g is 0.4 g minus mu times 0.8 g cos 30 is equal to 0.8 times 3/5. So that will give me mu times 0.8 g cos 30 degrees will be equal to 0.4 g minus 0.8 times 3/5. So then we can say, therefore, mu is 0.4 g minus 0.8 times 3/5, all divided by 0.8 g cos 30, and we're going to round mu to 3 significant figures. So we can just do it on our calculator. So we get 0.4 times 9.8 minus 0.8 times 3/5. And then on the denominator we get 0.8 times 9.8 times cos of 30. And that will give me 0.5066. And so on. So I'm going to round that to 3 significant figures. So therefore, mu is 0.507, correct to 3 significant figures.